Welcome to the deep dive. Today, we're uh, cutting straight to something really fundamental about the AI systems we use every day. It's this, well, surprising and maybe a bit unsettling fact that they often don't know when they're wrong. And crucially, they can't really accept corrections when you point out a mistake.
Yeah, it's not just a software bug, it seems to be more of a structural issue. And we're looking at a really fascinating source today, a piece called Ansha AI that translates roughly to error-blind AI versus controlled AI. It gives a really clear breakdown of why current AI is often built this way and what that implies we really need to do about it.
Okay, right, let's dive into that. So our mission here is to understand these limitations the source is talking about, what makes AI error blind and solution deaf, as they put it. We'll get into the specific ways these errors actually show up, and importantly, explore this idea of a higher intelligence that the source says is essential to manage these systems. You might think AI just keeps learning and getting better, but this source suggests there's a kind of hard limit there, and, well, the implications are pretty big.
Definitely.
So, according to the source, where does this core problem really start?
It begins with the absolute basics of how current AI actually learns. It essentially builds its whole understanding by spotting patterns within a finite collection of training data.
Right. It learns from the specific examples it's been fed. Makes sense.
Exactly. But then you hit the core conflict. The real world isn't a neat, finite data set. It's practically infinite. There are endless variables, exceptions, things happening that just weren't in that original training set. Ah, okay. So that mismatch, that gap between the AI's limited learned patterns and the infinite complexity of reality, that's where the errors come from.
That's precisely the argument the source makes. Errors aren't just occasional glitches. They're almost an inevitable result of this fundamental mismatch. And what's really striking, the source points out, is that when these errors do happen, the AI often doesn't even have the mechanism to recognize it as an error.
It just keeps going.
It just confidently applies its learned limited patterns to a situation where they just don't fit. It acts certain even when it's completely off base.
Wow. Okay, so it's acting with certainty even when it's wrong. That leads us to this idea of error spots you mentioned the source brings up, like specific ways this blindness manifests.
Yes, exactly. The source focuses on two main types of these. Let's call them structural error points. The first one is generalization mismatch.
Okay, generalization mismatch. So is that like the AI learns a rule from its specific training data, but that rule doesn't actually work universally out in the real messy world? That's it, precisely. It forms a kind of local generalization that seems perfectly fine within the confines of its training data. But that generalization just breaks down when it encounters the infinite variables and complexity outside that initial set. The source uses a really good example. Imagine you train an AI only on pictures of white Arctic foxes.
Got it. So its internal pattern becomes something like if it's an Arctic fox, it must have white fur. Simple rule.
Right. Now, what happens when you show that AI a gray Arctic fox? Maybe one that's molting its fur for the season.
Uh, the AI wouldn't recognize it. Even though it is an Arctic fox,
Yeah.
its learned pattern white fur doesn't match the reality of this gray fur variation.
Correct. The learned generalization is just too narrow, too specific to the training data for the dynamic reality it encounters. The second type of error spot the source talks about is pattern mismatch.
Okay, pattern mismatch. How's that different from the generalization one? Is this more about dealing with things that are totally new or situations that change over time?
Yes, that's a really key difference. Pattern mismatch happens because the AI relies heavily on these fixed patterns it learned from past data. But reality, of course, isn't static. It's always changing, always throwing up new or unusual situations. The AI essentially tries to cram these new inputs into its old fixed categories.
Okay.
The example the source gives here is pretty clear. Say you train an AI just to tell the difference between dogs and apple.
Okay, visually very distinct categories. Should
Right.
be easy,
Right. Now, show that same AI a picture of a fox.
which it never saw during training. It only knows dog and apple.
Exactly. The AI's internal world is structured around the patterns defining dogness and appleness. When it sees a fox, it doesn't have a foxness pattern, so it tries its best to fit the fox into one of the categories it does know based on whatever superficial features seem closest. The source suggests it might incorrectly label the fox as a dog.
Maybe because it sees four legs and fur, kind of like the dogs in its training set, even though fundamentally a fox isn't a dog.
Precisely. Its fixed, pre-learned patterns just aren't sufficient to correctly classify something genuinely new that falls outside those established patterns.
Okay, so the source points out these structural traps. Generalization mismatch, where the learned rules are too local for the wider world, and pattern mismatch, where fixed old patterns just can't handle new or changing realities.
Mhm.
And this fundamental inability to correctly process the real world leads us straight to the source's really core concepts: error blindness and solution deafness.
Yes, these are the two fundamental limitations the source really hammers home. Error blind means the AI literally doesn't detect or recognize its own errors when they happen. And solution deaf means it structurally cannot accept or integrate external feedback or offered solutions, even when told it's wrong.
Why? Why can't the AI just realize it made a mistake? Like a person might go, whoops, my bad, got that wrong.
Well, the source lays out several reasons, and they're pretty deeply rooted in how these AI systems are actually built. Fundamentally, it's constrained by its statistical learning approach. It's basically performing probability matching against its training data, figuring out what's most likely based only on patterns it's seen before. It doesn't operate with an inherent concept of objective truth or correctness in the human sense.
So it's finding the statistically best match based purely on its past experience, not actually understanding the underlying reality of what something is.
Exactly. It also lacks something called metacognition, the ability to think about its own thinking process. It doesn't have a built-in criteria or an internal feedback loop to evaluate its own output as potentially wrong.
So it can't kind of step outside itself and analyze its own judgment from a more objective viewpoint.
Precisely. Which ties into the third point the source makes. It can't self-reference in that way. It lacks that higher level ability to evaluate its own conclusions objectively. And the really crucial takeaway the source emphasizes here is, well, it's quite profound. Because of this structure, the AI cannot actually experience errors internally. And because of that, it can't really talk about them meaningfully. It just doesn't have the internal framework.
That's a bit chilling when you think about it. It makes a mistake, maybe one with real consequences, but internally, it doesn't register as an error, and it can't even communicate about it.
It's a massive difference from how humans handle errors, right? And then connected to that is the solution deafness. Even if we, as external observers, spot the error, if a human points it out and says, no, that's incorrect, the AI doesn't really have the capacity to take that feedback and use it to fundamentally change its understanding or behavior.
Why not? Can't you just tell it it's wrong and have it learn?
The source explains this is also a structural limitation. Current AI systems, once they're trained and deployed, typically operate based on fixed algorithms. They aren't really designed for real-time modification of their core logic based on just one piece of external feedback.
So it's not like having a quick chat and saying, hey, remember this specific correction for next time.
Not in a way that truly overrides the immense statistical weight of its original massive training data set. Its outputs are kind of locked into the patterns derived from all that data. One correction just doesn't carry enough weight against that history. And critically, the source highlights the lack of a properly designed feedback loop, a structure built to effectively take in external corrections and use them to genuinely alter its core behavior or understanding.
So even if you show it the gray fox and say, look, this is also an Arctic fox, it doesn't properly integrate that information to prevent the same kind of pattern mismatch the next time it sees a gray one.
Exactly. The source's conclusion here is pretty stark. Even when you tell the AI it's wrong, it doesn't truly comprehend it as wrong in a way that prompts structural change or genuine learning.
Okay, wow. So we've got an AI that's structurally prone to making errors. It can't detect, that's the error blind part, and it can't learn from being told it's wrong, the solution deaf part. This sounds like a potentially serious issue if we're relying on these systems for anything important.
Right.
But the source doesn't just leave us with the problem, right? It proposes a solution, this concept of meta AI.
Yes, exactly. This is where the source introduces the idea of meta AI, which it describes as a kind of higher intelligence. It's specifically designed to operate above the primary, error-blind, solution-deaf AI. Its job is to monitor, control, and basically supplement the capabilities that the main AI lacks.
So meta AI acts like a supervisor, a layer of oversight that the core AI doesn't have internally.
That's a very good way to put it. The source outlines some key functions for this meta AI. First, error detection. It needs to actively watch the subordinate AI's output in real time, specifically looking for those generalization and pattern mismatches that the AI itself is blind to.
Right. It's specifically hunting for those known blind spots.
Precisely. Second function, risk assessment. Once an error is detected, the meta AI needs to evaluate the potential real-world consequences. What's the impact, social, physical, financial, whatever the domain is? How bad is this particular mistake?
Yeah, misidentifying a cat picture on the internet is obviously very different from, say, misidentifying something critical in a medical scan or
Yeah.
messing up a self-driving car's navigation.
Exactly, which leads to the third function, intervention decision. Based on the type of error and the assessed risk, the meta AI has to decide if and when it needs to step in. This might mean halting the lower AI's operation entirely or perhaps modifying its output or actions.
It has the power to actually say stop or hold on, recalculate this.
Yes. And the fourth key function is learning adjustment. The meta AI needs to incorporate the patterns of the errors it detects. Not necessarily to directly reteach the lower AI in real time, because we just discussed why that's hard, but rather to improve its own future error detection capabilities, or perhaps to provide data that informs fundamental updates or retraining of the subordinate AI later on.
This whole process sounds very much like, well, like human reflection, doesn't it? We make a mistake, we think about why it happened, and we try to adjust our approach so we don't make the same mistake again.
The source explicitly draws that parallel. Humans possess this capability for metacognition, for self-correction. The AI, as currently structured and described by the source, fundamentally lacks this. So this meta AI layer is essentially an attempt to build that crucial oversight and correction mechanism externally.
Okay, and this really brings us to the core motivation the source gives for why we absolutely need this meta AI layer. It's not just about making the AI slightly more accurate. It seems to be about fundamental safety and reliability, given these inherent limitations.
Exactly. And that's where the source brings in that famous quote from the philosopher Wittgenstein. What we cannot speak about, we must pass over in silence.
Okay, interesting quote. How does that connect specifically to this error-blind AI?
The source applies it quite powerfully. The argument goes like this. The AI makes errors it cannot speak about because, as we've established, it's internally blind to them. It doesn't know what's wrong. But, and here's the crucial part, when a third party, whether it's a human user or this proposed meta AI, does detect the error and points it out, the AI doesn't then simply pass over it in silence. It doesn't stop. It doesn't acknowledge the mistake. It doesn't correct itself. It just keeps operating incorrectly, still blind to the problem.
Ah, okay, I see the connection now. So because the AI itself won't self-correct or even stop when an error is identified externally, we need this higher intelligence, the meta AI, specifically to step in and enforce that necessary silence to make it stop or change course when it's wrong.
Precisely. The fundamental purpose of the meta AI, according to this source, is really twofold. First, to detect the errors the primary AI is blind to, and second, to make the AI stop or alter its behavior based on that detection. It has to impose control because the AI lacks the internal capacity for self-control in the face of its own errors. It's about ensuring safety and reliability through external management.
Right. So let's try and bring this all together then. What are the absolute key takeaways from this source, this error-blind AI versus controlled AI?
Well, the core conclusions seem to be first that current AI systems have these inherent structural limitations, these generalization and pattern mismatches that naturally lead to errors when interacting with the complex real world. Second, because of how they learn and operate, these AIs are fundamentally error blind. They don't recognize their own mistakes. And third, they are solution deaf. They lack the structure to effectively learn from or incorporate external corrections.
And crucially, these aren't just like minor software bugs you can easily patch with the next update, right?
No, the source strongly argues that this blindness and this inability to learn from being told it's wrong are deeply structural. They can't really be fixed within the AI itself without a fundamental redesign of its architecture, which current systems generally lack.
Which then logically leads to the conclusion that we need some kind of higher control structure, this meta AI concept, to actively manage and guide the inherently error-blind and solution-deaf AI if we wanted to produce reliable and, importantly, safe results.
That's the central argument, yes. Reliability and safety, particularly in high-stakes applications, seem to necessitate this kind of external oversight and control precisely because the AI itself lacks internal error awareness and the capacity for correction.
So, thinking about you, listening to this right now, you probably interact with AI systems constantly, maybe without even realizing it sometimes. It's in your search results, your social media feeds, recommendation engines, maybe creative tools, navigation. Why is it so important for you to understand this core idea that the AI driving these things might be fundamentally blind to its own mistakes and unable to just learn when someone points out it's wrong.
I think it really shifts how we should view AI. Instead of seeing it as this ever-improving, almost human-like intelligence that always gets better, we should recognize it more as an incredibly powerful but also fundamentally limited tool. A tool that, especially when used for critical tasks, requires very careful oversight, validation, and potentially, as the source suggests, active control systems to mitigate its inherent blind spots.
Yeah, that makes a lot of sense. This deep dive into error-blind AI versus controlled AI really does expose, well, a pretty critical challenge in how we're developing and deploying AI today. The source makes a very compelling argument that these systems we're building are structurally blind to their own failures and deaf to our attempts to correct them directly, which really underscores this urgent need for something like the meta AI layer they propose.
It definitely leaves us with a significant question to ponder, doesn't it?
It does. Given this analysis that current AI is fundamentally blind to its errors and can't really learn from being corrected, what are the potential risks?
Sure.
What are the dangers we face as we deploy increasingly powerful AI systems into really critical parts of our lives? Thinking about healthcare, transportation, finance, security. What happens if we push ahead without implementing this kind of robust external meta AI layer of control and validation that the source argues is so necessary?
That's definitely something important to keep in mind as these technologies become even more deeply integrated into our world.
Indeed it is. Thank you for joining us for this deep dive.